steel at your yield point, and that is taken as the yield strength of steel divided by the modulus of elasticity of your steel, or Fy over Es. Then we have the rho, that is the ratio of tension reinforcement, or sometimes it is called the steel ratio, and was taken as the area of steel divided by B times the D. We have rho sub B, that is the balance steel ratio, wherein in this situation, your concrete and steel yields at the same time. So pareho niyang naabot yung maximum yield strength nilang dalawa. So that is the balance steel ratio. And also we have phi, that is the reduction factor, which will be discussed also later on based on your NSCP 2015. So meron tayong iba-ibang phi or strength reduction factor. So these are the notations and symbols na you will be encountering with the ultimate strength design of your beams. So let's take the provisions on the ultimate strength designs and some of the assumptions in this method of designing beams. So provisions and assumptions. First, we have the basic design principle or basic design relationship. And what is this basic design relationship? The basic design relationship is that the resistance must be greater than or equal to the load effect. So, ano ba yung mga load effect? So, those load effects are also called demands. So, these are the loads that are being carried by the beams or the structure itself. When we talk also about resistance, this means the capacity of your beam or your structure. So, ano ba yung capacity niya? Siyempre, hahawakan niya yung load. Sure. So, ano ba yung capacity niya? Siyempre, hahawakan niya yung loads. Sino ang maghahawak ng load? Yung concrete and also the steel. So, this is the basic principle. Dapat yung resistance ng isang structural element must be greater than or equal to the load that are being carried by it. Or else, mag-fail yung structure mo. So dapat it must be greater than or equal to the load effects. So that is the basic principle of your design relationship. Also, in doing so, we have what we call the nominal resistance. This nominal resistance implies that the resistance is a computed value based on the specified concrete and steel strengths, and also the dimensions of the cross section of your structure. The required strength is the combination of all the factored forces. So, for example, we have a beam. Meron tayong beam, kunwari. And then we have a live load. So this is WU or W sub U. So this is a live load, and the weight of the beam is the dead load. So when we are talking about the nominal resistance, sino ba yung maghahawak dyan sa load na yan? So the cross section of your beam, we have your concrete and your steel. So sila ang hahawak sa dead load and live load. And the required strength of this must be the factored loads. So these factored loads will be these loads will be factored. So the dead load plus live load. So when we are talking about factored, ibig sabihin hindi lang yung working stress ang ina-assume natin. So naglalagay tayo ng factor, let's say a blank DL plus a blank LL. So yun ang kaibahan ng working stress dun sa ultimate strength. And at the same time, in the working stress design, ginagamit natin yung full capacity. In working stress design, we are ginagamit natin yung full capacity ng beam. Whereas in the USD, yung full capacity na yun, binabawasan ulit natin, naglalagay tayo ng factor, which will be discussed later on, that, and that factor will be the phi, yung kanina. So that is the factored moment. So kumbaga parang, let's say, in WSD, itong beam na ito, itong given beam na ito, kayang maghawak ng 200 MPa, kunwari, na load. In USD, yung 200 na yun, hindi natin gagamitin lahat. Ina-assume natin na, let's say, 150 lang ang kaya ng beam. And then at the same time, let's say, for example, the dead load plus live load. The dead load plus live load, let's say, that is, so kung 200 na, let's say 190 MPa. Kunwari lang. So, dito sa working stress design, mapapansin mo na kayang-kaya niya yung beam. Kasi 200 yung kaya ng beam. Tapos yung load mo lang is 190. Pero dito, pag nilagyan natin ng factor, binawasan natin yung kaya ng beam. Let's say 150. And then, ito naman, dinagdagan natin kasi ifa-factor out din natin to. Yung 199, tataas pa, let's say 210 MPa. So pagdating sa USD, mapapansin mo na mas mataas na yung beam. Ibig sabihin, mag-fail na siya dito sa USD. So kumbaga parang, what we call this, nilalagyan natin siya ng factor of safety, parang ganun. Hindi natin ginagamit yung totoo niyang lakas, at the same time, nagdadagdag naman tayo dun sa loads. So yun yung kaibahan niya sa working stress design sa ultimate strength design.
May text ang sa'yo. May text ang.
Then we have the table for your load combinations. So ito yung ginagamit natin. In the past, meron tayong code na 2001. But the latest, we have the NSCP 2015. And we are waiting for the new code, which is brought by some of the typhoons na malalakas. So every now and then kasi, nagre-revise tayo ng code based on the prevailing, what you call this, prevailing situation. Like for example, nagkaroon tayo ng medyo malalakas na bagyo in the past. So baka ma-revise ulit itong 2015 na code. So these are the load combinations. Like for example, the combination of your dead and live. So in NSCP 2001, that is 1.4 dead plus 1.7 live. In NSCP 2015, naging 1.2 dead and 1.6 live load. Then for dead, live, and wind, ito yung combination niya. Pero sa NSCP 2015, ito na siya. So, and so forth, and so on. So, dati, ano ba yung napapansin nyo dyan sa combination na yan? So, bakit kaya hindi nila pinag-combine yung dead load plus wind load plus earthquake load? Bakit kaya? Any idea? Raven Aquino. Meron ba si Raven Aquino?
Sir,
So, bakit kaya walang dead load plus wind load plus earthquake? What do you think? Any idea? Wala? How about Mark Vincent Serapion? Mark
sir,
Vincent?
kung idea, sir.
Oo. Bakit kaya?
Sir, di ko po alam, sir.
Walang idea?
Wala
Any
po.
guess? Chine Almazan.
I don't have any idea po.
Wala din. Because in the past, wala pa namang nangyaring ganyan. Di ba? So, in the past, wala pa naman tayong naranasan na nag-earthquake tapos ang lakas ng bagyo. Parang ganun. But in the future, maybe it will come out later on. Di lang natin alam. Yun nga, dati-rate dun sa wind load, way back 2001, I think ang prevailing is mga 200 kph lang. And then, we have here the Yolanda na umabot ng hanggang 300 kph. Mga ganyan, I think. Mga 300 kph yung wind, yung lakas ng bagyo. So, nabago dun sa code ulit noong 2015. And then, we have also the water pressure coming out, I think, last year ba? Last year. Yung mga typhoon. So, they are revising again the NSCP 2015 based on the current situation of the country. So, yon. Actually nga, medyo nahuhuli tayo sa pag-revise. Kung napapansin nyo, ang layo from 2001, saka lang sila nag-revise ng 2015. In other countries, like for example, yung mga ginagamit natin na pinagkokopyahan yung mga ACI, ano pa yung mga code na yung we have the National Building Code, or also ano pa ba yung mga yan? Halos every year nagpapalit sila. Nagre-revise sila every year yan, yearly. So yun, i-revise natin sila based on the current situation. Next, we have the design strength based on your nominal moment and the strength reduction factor. So based on NSCP, the design strength for flexure, para sa flexure, dapat yung factored nominal moment must be greater than or equal to the ultimate moment. So this is the capacity, yung kanina, yung basic kwan natin. So this is the capacity and this is the load. Effects or the resistance. Capacity or the resistance. So that is the basic design relationship. So dapat si nominal moment factored by your phi must be greater than or equal to the ultimate moment computed using the factored loads. For shear, which will be discussed also later, ganun din, the factored nominal shear must be greater than or equal to the ultimate shear. For torsion, factored nominal torsion must be greater than or equal to the ultimate torsion. And for axial, the factored nominal strength of your column must be greater than or equal to the ultimate strength of your column or axial force. When we talk about your nominal moment, yung MN na tinatawag natin or M sub N, that is the capacity, yung capacity niya. So this is the capacity of your cross section. Composed of your concrete and steel. And then we have the strength reduction factor or your phi. So your strength reduction factor or phi that is used to account for possible variation. Kumbaga nagbibigay ka ng pwedeng mangyari na lumaki in dimension or lumiit yung dimension, or also the material, baka biglang pumalya yung steel mo. So nilalagyan mo siya ng strength reduction factor or phi. Also, baka may mga inaccuracies. Hindi maganda yung pagkakagawa ng beam, parang ganun. So, to account for those inaccuracies also. Kumbaga parang kung sa tao sana, yung isang tao, nakakabuhat siya, let's say for example, yung isang tao, ang capacity niya is nakakabuhat siya ng, let's say, nakakabuhat siya ng 200 kilogram. So, hindi mo naman, kumbaga, wag mo siyang ipabuhat ng, ang principle ng ultimate strength design. So, ito yung capacity ng tao, 200 kilogram ang kaya niyang buhatin. Pero, wag mong ipabuhat sa kanya yung 200 kilogram. Parang ganun. So, ipabuhat mo sa kanya mga 150 lang, parang ganun. Wag mong isagad dun sa capacity niya na actual. Unlike in the working stress design, talagang ipapagamit mo yung buong 200 kilogram. Parang, sige, ipabuhat mo na yan. Kayang-kaya naman niya yung 200 kilogram. Sa USD, 150 na lang para sigurado. Parang ganun sana. So, nilalagyan mo siya ng strength reduction factor dun sa capacity niya. So, strength reduction factor. So, these are the strength reduction factor. For letter A, for structural elements resisting moment, axial force, or combined moment and axial force, your reduction factor is 0.65 to 0.9 in accordance to 421.2.2, which will be discussed again later. So, saan mo gagamitin yung 0.65, saan mo gagamitin yung 0.9 based on the 421.2.2 of your NSCP 2015. But there are exemptions. If it is a pre-tensioned members where strands not fully developed, phi shall be in accordance with 421.2.3. Yan. For shear, 0.75. For torsion, 0.75. Bearing, 0.65. Yan. Post tension, 0.85. Brackets and corbels, 0.75. For struts, ties, noddle zones, and bearing areas, 0.75. Components of connections of precast, so 0.9. Plain concrete elements, 0.6. And anchor in elements, that is based on section 417. So these are the strength reduction factors to be used. For pretension, so these are the strength reduction factors, so andyan, which will be discussed later when we go with the pretension module. So those are provisions. Let's go with the some assumptions for this USD. Ano ba yung ina-assume natin pag USD ang ginagamit natin? For concrete, we are assuming that the concrete cracks at the maximum strain. And what is again the maximum strain of concrete? Rensledge, Tayaban? What is again the maximum strain of concrete? Ano?
0.003.
0.003.
003.
So we are assuming that the concrete cracks at the maximum strain of concrete, that is 0.003, that is epsilon sub c. Also, we are assuming that the depth of concrete stress blocks is equals to beta 1 c. And also in according to NCP 2015, concrete stress of 0.85 FC prime shall be assumed uniformly. So uniformly. Pero in actual, hindi naman siya uniform talaga. Uniformly distributed over the equivalent compression zone. So uniformly distributed siya. So if this is the stress block, so this is your tension, this is your NA, the alpha. So alpha, ito yung alpha, or the depth of the stress block is equals to beta 1 C daw. So we are assuming. And then the stress block of concrete is assumed to be uniformly distributed dito. So na-assume natin na uniformly distributed siya with 0.85 FC prime. Yan. So ano pa? Also in NSCP, the distance from the fiber of maximum compressive strain to the neutral axis, that is C, shall be measured perpendicular to the neutral axis to NA. So it is assumed that the depth or the distance from maximum fiber or maximum compressive fiber strain to neutral axis is perpendicular to NA. So this is NA. The distance from extreme compressive up to the neutral axis is C, and that is perpendicular, taken as perpendicular. So the value of beta also is taken as, for the value of beta, that is 422.2.4.3 of your NSCP. So take note nyo yan, 422.2.4.3. May mga formulas dyan. Given the FC prime, what is beta? 1. So yan, 422.2.4.3. For assumptions for non-pre-stress steel reinforcement, the strain in concrete and steel shall be assumed to be linearly proportional to the distance from neutral axis. So strain of your concrete and strain of your steel is linearly proportional. To the distance from NA to concrete compression fiber. And in the neutral axis, that is equals to 0. So what does it mean? So this is the neutral axis. 0 daw yung strain niya dyan. And then in the concrete, it is assumed to be cracked at 0.003. Yan. And in the steel, that is epsilon T. So that is the strain diagram. So 0 sa NA, and then linearly proportional. So nagbabari siya linearly pabalik dun sa steel. So ano pa ang mga important points? Also for non-pre-stress bars, the stress below your Fy shall be ES times steel strain. So the stress below Fy shall be ES, or the modulus of elasticity of the steel. This is multiplied. ES multiplied by your steel strain. And modulus of elasticity shall be 200 GPa. So, yeah. So, this is for case 1. But in case 2, if Fs is equal to Fy, so nag-yield yung steel, that is epsilon S or epsilon T is greater than epsilon Ty. So, yeah. Ito is if epsilon T less than or equal epsilon Ty. Again, let's review for singly reinforced beam. So we have here singly reinforced for the stress block. Oh, sobra. So this is tension brought by your steel This is the neutral axis. Then we have the stress block of the compression taken as 0.85 of FC prime. So we have here the compression. This is alpha. Ano pa? The distance from extreme fiber up to NA. This is C. Then the distance from the centroid of this up to the compression fiber. This is D. Yeah. So this is the stress block. And for the strain, oops, so 0, yeah. This is 0.003. So this is C. Epsilon T. So this is D minus C. So this is your strain diagram. So nakuha yung mga elements.
Wala.
Wala si Sir.
Sorry, nawala yung screen. Can you see the screen?
Yes, sir.
Wala ako bigla. Sorry. So, napicturean nyo ba yung last? Assumptions. So, again, we will try natin ulit. So, for the singly reinforced, we have here the neutral axis. Then we have the stress block. So this is the tension brought by steel. And for compression, that is 0.85 of FC prime. So this is compression. This is alpha. This is C. And this is D. And for your strain, this is taken as 0.003. And this is epsilon T. So this is C. And this is D minus C. So these are the elements of your singly reinforced. So this is stress. And this is strain diagram. So from these diagrams, we can have the basic equations for the ultimate strength design. So ano yung mga basic equations? So, napicturean nyo na? Okay na? So, let's proceed with the basic equations for the compression. So, area lang naman siya nung stress block. So, that is equals to 0.85 FC prime multiplied by the area of concrete. For the strain, that is equals to, so 0.003 multiplied by D minus C over C. For the steel tensile stress, that is equals to 600 D minus C over C. But that must be less than Fy. So hindi nag-yield yung steel. For non-yielding tension on steel, when we say non-yielding, Fs is less than Fy. So non-yielding. Ano ibig sabihin pag sinabi nating non-yielding? Hindi niya tawag na ito, hindi niya na-achieve yung yield strength nung steel. So ibig sabihin, nag-yield yung concrete pero yung steel hindi siya nag-yield. So those are instances na medyo delikado because ang ibig sabihin nun is over-reinforce yung structure mo. So for non-yielding, tension is equals to AS times Fs. But for yielding, that is Fs greater than or equal to Fy. So this is for yielding. Your T is equals to AS Fy. For the nominal moment, so that is M sub N C times D minus C over 2. Or it can be also T times D minus C over 2, the moment arm. For the design moment, we can have phi mn, phi c d minus c over 2 e d minus c over 2. So these are your equations, basic equations. And for reduction factors, based on NSCP 2015, so these are your reduction factors. For compression controlled, that is E sub T or epsilon T is less than or equal to epsilon sub Ty, 0.65 for beam and column, and 0.75 for spiral column. For tension controlled, epsilon sub T that is greater than or equal to 0.005, the reduction factor is taken as 0.9. And for transition, that is wherein epsilon sub T is greater than epsilon sub Ty but less than 0.005, we have here the formula 0.65 plus 0.25 quantity epsilon sub T minus epsilon sub Ty all over 0.005 minus epsilon sub ty. For singly reinforced rectangular beam. So again, we recall, kasi halos parehas lang naman ito. So the stress block at NA, so this is T, that is equals to AS Fy for yielding. For yielding ito. Kung hindi, AS Fs kung non-yielding. Taken as 0.85 of Fc prime. This is alpha. So this is C. Yeah. So this is C, or 10 compression, that is equals to the 0.85 Fc prime multiplied by alpha times B. Then we have here the strain 0.003 epsilon sub C and then epsilon sub T. That is equals to Fs over Es. This is D minus C and this is C. So again, from this situation, we have summation forces horizontal that is equals to 0. So that is C equals T from the stress block. So summation forces horizontal tayo equals 0. Dalawa lang naman yan. Si C papunta sa left and si T papunta sa right. So equals 0, that is equals T. So the moment. Mag-moment tayo sa dalawa, that is equals to couple. So kunin yung moment arm. Anong distance? Ito. So this is D minus alpha over 2. Tama? So D yung buo. Ito yung D. I-minus mo ito. Itong distance na ito. This is alpha over 2. Ito. This is alpha over 2. So its moment arm is D minus alpha over 2. So your moment, that is equals to C or T multiplied by the moment arm. Yan. So depende kung given yung C, gamitin mo yung C. Kung hindi, gamitin mo yung T dito. So makukuha mo yung moment. Also, kung T naman, so kung C muna. So if C ang gagamitin natin, so M equals, what is C? That is 0.85 Fc prime alpha B multiplied by D alpha 2. But what is alpha? Ano ang alpha? M is 0.85 Fc prime. This is beta 1C, di ba? Multiplied by B, multiplied by the moment arm. Yan. So, kung T naman, so palitan mo lang ng ESFY. So, that is M equals ES Fy kung yield. If it did not yield, not yielding, use Fs. So, multiplied by D o minus alpha over 2. Or AS, FS, if not yielding, D minus A over 2. So yan, mga basic equations pa natin yan. So have you already taken the picture? Okay, so next, from those formulas, balik-balik nyo lang naman yan. So ito is nanggaling din lang dun sa basic formula na yan. So alpha equals ES-FY all over 0.85 FC prime B. So yan. Also, alpha equals your rho Fy D all over 0.85 Fc prime. Because rho is equals to AS over BD. So this is in terms of your rho. Also, alpha is equals to rho Fy over Fc prime. So depende sa given. So your general formula now, para madaling matandaan, is phi mn. Kasi kailangan yung tandaan talaga. So phi rho Fy BD, this is BD. BD squared 1 minus 0.59 rho Fy over Fc prime. Or that is equals to phi mn rho omega Fc prime BD squared 1 minus 0.59 omega. Where omega is equals to ito. Yan. So this is to be used for singly reinforced rectangular beam. So omega Fc prime BD squared 1 minus 0.59 omega. Where omega is equals to rho Fy over Fc prime and rho is equals to AS over BD. So nakuha. Take pictures. Okay na. So there is also what we call a flexural. Kung minsan tinatanong kasi sa board exam ito. What is the flexural resistance factor? So the formula for flexural resistance factor is R equals rho Fy 1 minus 0.59 rho Fy over Fc prime. Yan. So basically, ang VMN mo can also be equals to rho R BD squared. So yan. So halos majumbo-jumble lang naman. So you can also use this general formula. Other important points, meron din tayong tinatawag na balance condition. When we say balance condition, when there is a simultaneous yielding of your concrete and steel, kung sabay silang nag-yield. So that is equals the C must be equal to T. So nag-yield sila pareho. Ito yung pinaka maganda because when the two yields at the same time, magkakaroon ng parang warning pa, kumbaga. Unlike if the concrete yields first, ang nagkakaroon kasi ng parang kumbaga over-reinforce. So hindi rin maganda kasi pag masyadong marami yung bakal na nilagay mo. Magkakaroon tayo ng over-reinforce. If this happens, your concrete yields first. Then steel. So when kapag nangyari ito, kapag nag-crack yung beam mo, babagsak na lang bigla yung concrete. Wala na siyang warning. Yun yung nagkakaproblema dito if there is an over-reinforcement. And when concrete yields first than the steel. So this is your beam. Kung concrete ang naunang bumagsak, ibig sabihin, when we say yields, siya ang unang babagsak kaysa sa steel. So when concrete yields first, wala nang warning yan. Mababagsakan ka na agad nung concrete. So kung nag-crack yung concrete mo, itong portion na ito, babagsak na agad yan. May iwan na lang doon, nakikita mo, buo pa yung bakal kasi hindi pa nag-yield yung bakal, hindi pa na-achieve yung kumbaga parang baseline na strength niya. So if that's happened, we have what we call the raw balance or the balance steel ratio. And this is computed as 0.85 FC prime beta 1 over Fy multiplied by 600 divided by 600 plus Fy. And take note this, these formulas must be memorized kasi hindi rin nila binibigay in the board exam as given. So these are basic formulas. 0.85 beta 1 or FC prime beta 1 over Fy multiplied by 600 plus 600 plus Fy. Ayan. So that's it. So any questions or clarifications regarding the introduction on the ultimate strength design? Jairel Solidaga, do you have any questions or clarification? Wala. So let's have a review. So let's have a review on USD. May I call on a short review lang kung ano yung mga nakuha natin. Jason Lee, Makadangdang, are you there? And at the same time, I'm checking attendance na rin. Jason Lee? Wala. How about Flory May, Flory Bacaro. Flory Bacaro, are you there?
Good evening, sir. Sir, good evening.
And what is the difference between working stress design and ultimate strength design? Can you give one difference of the two? Working stress and ultimate strength design. Flory Bacaro?
Sir,
Again? Ano?
sir, sa ano po? Sir, sa working stress design po capacity. Unlike po sa
Unlike?
sa US. Sir, yun.
Sa USD is ano? Hindi natin ginagamit yung full capacity, di ba? Kumbaga kung sa working stress design sana, ang kaya ng jeep na ito is 20 na tao, parang ganon. Kung sa ultimate strength design, hanggang 18 lang na tao yung jeep. So, full capacity yung isang beam.
Opo.
So, nilalagyan natin siya ng safety factor, kumbaga. Okay, so thank you. How about Colin Joy, Concepcion? Colin Joy, Concepcion? Meron ba si Colin Joy? Wala. Si John Mark Tundagi. John Mark Tundagi.
Hello.
So, what is again the basic design principle?
Sir, yung basic design principle, sir?
Mm-hmm.
Sir, yung resistance is equal or greater than load effect?
Mm-hmm. And what is the explanation of that?
Sir, sa resistance, sir, is yung capacity pa? Ano to? Sir, yung concrete is steel. And then sa load effect, sir, is yung demands.
Demands, mga bubuhatin niya, mga loads, parang ganun, di ba?
Mga loads niya, sir.
Okay, so thank you. And how about Crisalin Del Rosario? Crisalin
Yes,
Del Rosario? Crisalin, dyan ka ba?
Yes, sir. Nandito.
Anong mas maganda? Mas maraming bakal or kokonti ang bakal? Kung papipiliin ka lang ng isa. Mas maraming bakal or kokonti ang bakal? Bakit?
Sir, para po sa akin, mas maraming bakal.
And why?
Sir, pag maraming bakal po kasi hindi ka po, tawag dito, parang makukulangan. Parang ganun, sir.
Mm-hmm. How about,
Sa-
sige, thank you. How about Zen Sabado?
Po, sir.
Zen Sabado?
Sir,
Anong mas maganda? Mas maraming bakal o kokonti ang bakal? Kung
Mas
papipiliin ka ng isa.
sir, mas maraming bakal, sir.
Bakit?
Sir, kasi parang pag mas maraming bakal, parang mas madaming susupport sa...
So, support sa beam, di ba?
Yes, sir. Opo.
Tama ba? How about Jenny Galasinao? Jenny Galasinaon, dyan ka ba?
Sir,
Yan. Anong mas maganda para sa'yo? Yung maraming bakal or kukunti ang bakal?
sir, yung mga
Bakit?
parang sir. Hindi maano yung
Hindi. Hindi. Itong binibilugan to.
Masira po.
Masisira yung concrete.
Ay, ano ba?
Hindi
Babagsak.
masisira o ano? Yes. Between over-reinforced and under-reinforced, kung ako papipiliin mas gugustuhin ko ito. Yung under, yung kukunti ang bakal. Kasi if over-reinforced, there is a tendency that the concrete will yields first. And that is very dangerous. Kumbaga kung ito sana yung beam mo, andito yung bakal mo, ibig sabihin pag under-reinforced, mas unang mag-fail yung bakal mo kasi kukunti nga eh. Kung nag-fail yung bakal, so syempre itong bakal mo sa loob, mapuputol. So nag-fail eh. So naputol yung bakal mo sa loob. Nasa loob naman siya. So hindi naman siya babagsak agad. Unlike if the concrete yields first, buo pa yung bakal mo, pero natipingan na aji beam mo. So ito yung bakal mo, buong buo pa siya. Pero yung part ng concrete mo is nag-fail na. Ibig sabihin, there is a tendency, wala namang, ano nang tawag nito? Wala namang biglaan. Hindi siya, kumbaga wala siyang warning. So may tendency na babagsak agad yan sa'yo. But ang pinakamaganda sa kanila is the balance condition. So nakuha nyo yung difference ng tatlo. We have under-reinforced, balance, and then over. So hindi rin maganda na mas marami kang bakal. Yun yung isang kwan natin, kumbaga ano nang tawag na nito? Misconception ng karamihan. Kung hindi ka engineer, let's say kung ordinary yung foreman ka lang, parang kumbaga mas gugustuhin mo pa na mas maraming bakal, para mas sure kumbaga ganun, di ba? Pero in the actual, ito ang pinaka